and welcome to Addition and Subtraction Strategies in second grade. I'm Shanna Uwe.
And I'm Emily DeVizio.
Today we're going to focus on procedural reliability within 100. For your first task, please pause the video and you're going to complete the task on your own or with a team or partner. You're going to solve for the difference of 38 minus 17. As you're thinking through the task, determine different strategies second grade students could use to determine the difference, and also consider what connections students may make between the different strategies. We'll see you soon. So, progression with best. In first grade, they were adding 2-digit numbers and 1-digit numbers with sums to 100. They were subtracting a 1-digit number from a 2-digit number. They were using equations and explaining if they were true or false, and also determining the unknown whole number in an equation. In second grade, they're adding and subtracting 2 whole numbers within 100 with procedural reliability. And then they're adding and subtracting 2 whole numbers within 1,000.
Shanna, I thought we added subtracted numbers, 2 whole numbers within 100 in first grade.
We did, but now this year it's about procedural reliability, and we're going to get into what that looks like in a little bit.
Okay, that was my next question.
And then determining and explaining if addition and subtraction equations are true or false again, and then also the unknown. In third grade, they're adding and subtracting multi-digit whole numbers within 10,000, including standard algorithm with procedural fluency.
Oh, wow.
And then 1- and 2-step real-world problems.
So it seems like every year builds upon each other.
Exactly. In this video, we're going to focus on adding and subtracting 2 whole numbers within 100 with procedural reliability.
I'm excited to learn about procedural reliability.
I'm excited too. So to understand what procedural reliability is, we're going to look at the stages of fluency. So stage 1, you have your exploration, where you're really developing that understanding of the concept. In stage 2, that's when you're starting to get to procedural reliability. It focuses on the skills from the exploration and developing an accurate, reliable method that aligns with student understanding and learning style. So that's where we're going to get within this unit. And then stage 3 is when you achieve procedural fluency. That's when you're utilizing skills from the procedural reliability stage to become fluent with an efficient and accurate procedure that works all the time. And then embedded with stage 1, stage 3, automaticity. This is when you have that direct recall of basic facts.
I think that stage 2 is really important because that's where our students are able to be exposed to varying methods.
Yep.
That could support their way of thinking to solve the problem.
Yep, moving them to a little more efficient strategy from that exploration. And then it's not expected for students to use a standard algorithm in second grade. Students will formally learn the standard algorithm, a standard algorithm in grade 3 for addition and subtraction.
So if I'm not teaching them the standard algorithm, what should be my focus with addition and subtraction?
Still focusing on using those place value strategies and trying to get them to more efficient strategies using that place value.
Similar to first grade.
Yep.
Okay.
And then once again, we're not talking about the standard algorithm when we're talking in best standards. A standard algorithm is not our traditional the standard algorithm.
Where we practice the regrouping and costing out. It's more of whatever method a student chooses that works for them that's accurate and efficient.
Definitely.
Okay.
So this is what we kind of talked about earlier with procedural reliability. You're seeing a lot of repeating of the skills and strategies that they did the prior year, but now I'm going to do it with a little more efficiency.
Okay, makes sense. It's a nice visual to see the building blocks of what I'm teaching and where they're going.
Yep, and you can see in second grade, we're getting to that recall of the addition and subtraction within 20. And then you're also getting into that procedural reliability once again with adding and subtracting within 100. So within this unit, when we're adding and subtracting, we want to continue to use those place value strategies that they're familiar with from first grade. In second grade, we want to keep using those strategies like the base 10 blocks to model renaming and regrouping, and then also building number lines so they can see that I'm not adding 2, I'm adding 2 10s and actually see those jumps on the number line.
So it's important for them to explore those place value strategies to determine which would maybe be more reliable for them to use in that particular situation.
Yep. So through repeated use, I'm picking the strategy that's most efficient and accurate for me.
Exposure is definitely important here.
Yep. So as we're spending time connecting back to those strategies they used in first grade involving place value, addition, and subtraction, now we're trying to get to that representational stage where now I'm attaching equations to the models. And then after repeated use, I can maybe just focus on the equations.
And using one method that is reliable for me.
Yep.
This is more of like the representational, I feel, when we're talking about concrete representational abstract.
Yep.
I feel like this is more of the representational stage, right?
And seeing how I can break apart numbers to make it easier to add or subtract.
So if I have that place value exposure, it will support me with thinking flexibly about decomposing and composing numbers.
Yep. But I'm seeing and understanding it because I'm using the models to justify and connect it.
Makes sense.
Continuing with the place value strategies, sometimes when we're adding, we have more than 10 ones, and I'm going to have to group those 10 ones for a 10, and then vice versa. When I'm subtracting, sometimes it's necessary to decompose tens and regroup them to ones. So it's really important that we still do this concretely using those base 10 models so students understand why they need to regroup or rename.
You know, Shanna, you just said something that's really important. I feel like sometimes when we're in a crunch for time, or maybe we don't necessarily understand the purpose for a particular strategy, we teach it more procedurally, but we really need to focus on teaching that strategy for understanding so that a student may decide that's the most efficient and reliable method for them to use to solve the problem.
Yep, we need to force that place value understanding in everything they do to avoid those misconceptions and to really focus on the understanding.
Makes sense.
Relating addition and subtraction is also a great strategy to help students achieve that procedural reliability. I want to make sure that I'm using that number line model to show them the relationship between 38 minus 17 and 17 plus what equals 38. The more students are able to make the connections between addition and subtraction, the more procedurally reliable they'll become.
I also think that the place value exposure that they had and experiences will support them with decomposing those numbers to make those jumps on the number line. So I can see how this connects.
And you can see with the two number lines too that the space between the numbers is the same.
Right.
Like it's really the same problem. I'm just either going forwards or backwards.
What a way more powerful way to show how they relate versus just showing equations of a fact family per se.
Right. That's very abstract to students. So we want to make sure we're using these concrete models and representational models.
Yep.
The commutative property of addition is also a great strategy in property to help students with that procedural reliability. If I know 58 plus 35, I definitely am going to be able to use that to help me figure out 35 plus 58.
So it doesn't matter which way the add-ins are arranged or organized within the expression or equation.
But sometimes kids need to actually build it and see it to believe it. So we can't just tell them, oh, you flip the order and it's going to be the same. Let them actually feel it and do it.
Makes sense.
So to recap the strategies that we discussed for adding and subtracting within 100 with procedural reliability, we have our concrete base 10 blocks and number lines. Then we're moving to that representational where we're connecting equations to our models as well. And then when we're getting to the abstract, we have that commutative property of addition and partial sums even.
You know, I just had an aha moment. So I always thought that my end goal was to get to the abstract land and using just numbers and the equations. But now what I see with the standards, we're building on each grade level. So we're always going back to that concrete.
Exactly.
Even though we know how to solve the problem, we need to see it visually with those concrete models using larger numbers.
Definitely.
So I guess then what I'm trying to say is this needs to be fluid, right? So I may be in the world of abstract or on the island of abstract when it comes to adding, but I may need some of my manipulatives or representational thinking when I'm working with subtraction.
Yep. You got to go back to go forward, right? And keep making those connections. Think about how a strong bridge is built. You got to keep making connections back to each island. Thank you for joining us for the Math Dive in 5 addition and subtraction strategies with procedural reliability.
Have a great day.
Bye. See you next time.